Hey, welcome back, or I should say, I'm back. All right, it's gonna be a little sneak peek into the CCNP course that I'm creating. I decided to show you GRE and IP tunneling. Now, this is basic, very, very basic. This is really for CCNP, excuse me, and CCIE. No CCNA will have this question. You're not gonna see anything in the CCNA about GRE or IP and IP. Okay, let's just get that out there right now. All right, but when they do change the test, and I'm thinking they're going to change it fairly quickly, you may see this because this is very basic to do. This is something that they do on a daily basis out there in the real world. So I'm just going to show you the basic configs. All right, so GRE. So we're going to go over GRE tunnels. All right, we're going to go IP and IP. They're pretty much similar, and then I'll brush over what happens, the issues with recursive routing errors, meaning loops. But again, just touch upon it. All right. Generic routing encapsulation. That's what GRE stands for. It's point to point. If you got, let's say, like in our topology, we have 1, 2, 3, 4, 5 routers. They're connected. We have EIGRP running. I believe it's Autonomous System 100. But I want to create a tunnel. I want the information to go, when it does go, when the data does go through there, I want it to use the tunnel instead of just going through the interface. All right, because we want to be able to make it more private. All right, we want to be able, drop my pencil, make it more secure. That's all. But obviously, we have to do IPsec for that. All right, and we're not going to do it right now. So it uses the protocol 47. Why am I telling you this? Because it's something very basic that you need to know in case you're asked any questions on that, okay? So point to point uses IP protocol 47. And it supports any and all routed. Now routing, you didn't say that I said routing, routed protocols, IPv4, IPv6, IPX, CLNS when you're running ISIS. So it supports that, all right? GRE supports that. So now we know that. The next one. Now, before you create any tunnel, you must have a routing protocol in place. Or if you're doing static routes, that's just fine. Okay? But a routing protocol must be in place, and that is considered an underlay protocol. Why am I saying that? Because you could, to avoid running into the recursive errors, routing errors, the loops that I was telling you about, you want to run an actual routing protocol within inside the tunnel. So if you're running RIP, you may want to run EIGRP as your underlaying, right? Your reachability, right? That's what an underlaying protocol is. That's what we have right now. That's what's reaching across IP to IP, all right? Or point to point. And your overlay protocol will be the one inside the tunnel. All right, that's that. So then once we got that going, we create the tunnel interfaces. Again, basic, very easy. Interface, tunnel 0, tunnel 1, tunnel 200. Do I know what the max number of tunnels is? No, I do not. All right, I don't think I have to have gone that far to create that many tunnels. All right, then once you do that, you're going to create your tunnel destination. All right, or your tunnel source. It really doesn't matter if you do source or destination. You can flip them back and forth as long as they're both there. All right, so the tunnel source can be an IP address or can be an interface, whether it's a physical interface or it's a loopback interface. It does not matter. All right, as long as you have where you're sourcing it from. And then, of course, you have your destination. Where is this tunnel going to end? All right, so you got to let it know if it's, again, an IP address or an actual physical interface or loopback. All right, the payload, obviously, it's going to be, hey, are you pinging over there? Or are you sending it to any type of remote desktop, whatever it is, okay? Normally, it's just this, IP, v4, or v6, or what have you. Again, but this will work for GRE because it supports all those routed protocols. Now, IP and IP, it's pretty much the same. There's nothing really different except one, for the protocol number, and the way that you change it, and where's my little ball? Oh, it's over here. Let me put it here. Let me get my little handy dandy pencil. All right, it's this protocol number. So GRE is 47 and the IP and IP is 4. Okay, now you know, no big deal. All right, but again, testing purposes, you need to know. And maybe you're troubleshooting, you're looking at a something that you were analyzing, right? And you say, hey, we're running protocol 4. Oh, so we're running IP and IP. Even though the encapsulation will let you know you're running IP and IP, and the encapsulation will let you know that you're running GRE. So it'll tell you because that is the encapsulation. But again, what's going to change is going to show, another thing is that it does not support multi-protocol encapsulation, meaning it only supports IPv4, no IPv6, no nothing else, just straight out IP, okay? So there is no other support for anything else than IP version 4, okay? That's one of the, I guess, drawbacks with IP and IP tunneling. Let's go ahead and erase those red lines. We don't want to see them again. Let's go to the next slide. All right, the first thing, obviously, what you want to do is before you start, you want to verify your reachability. You want to make sure that your underlying, right, protocol is able to reach all the nodes across the network, right? That's the first thing you want to make sure you do. Then you start creating your tunnel. Again, the interface. Here we have it actually with an IP address, not the verbiage. The IP address, which is actually the payload, the tunnel source, and the tunnel destination. All right, and then you do the other one, the interface, the tunnel. There's the other router. All right, the IP address and the interface, then the source and destination. So it's the same thing. The only thing that's going to change is that you need to tell it that, hey, we're running the type mode GRE IP. Oh, I'm sorry, type mode IP. By default, it's type mode GRE IP. Okay, that's the difference. That's the difference. It's the mode that you're going to be running that in. All right, and we'll take a look real quick here. All right, and here it is right here. Let me get it back out, the pencil, so I can point it out to you. So it's already in red. This is the difference right here, besides the protocol number that I said. The tunnel mode, all right, the tunnel mode is IP and IP instead of GRE IP, which is the default. That's the default. So if you want to run IP, but remember, IP runs only IPv4. So keep that in mind. But the rest of it is the same. The rest of it is the same. No big deal. No big deal whatsoever. Okay? All righty. And then here we have a Wireshark. And again, this is from another lab. It is a Wireshark capture. And then you can see here in the header, all right, we have IP, obviously. All right, we have that we know. Again, let me get my pencil back out. I should have just left it out. We have the protocol GRE47. That's the encapsulation. That's how we know what we're running, right? It's called the shim header, all right, because it's in between the IP and IP. If you're running VLANs or whatever, it's going to be between the IP, GRE, IP, and then the payload. That's what's going to be in the layer 2 frame, okay? But if you do a capture, you know you're running GRE because it's right there. And if it isn't, you can tell by the protocol number. But it should be where you can see that, right? That GRE. And then the next one, let's just leave the pencil there. Well, no, I guess I can't do that, huh? Trying to be slick. There we go. Let me erase that because that looks nasty. Okay. And here, did I go backwards? Two. There you go. And here we have verification of the tunnel reachability again. But this time we're using IP and IP. All right. And we know this because of this number right there. It's going to tell you. Again, it's within the header. You have the first part of it, which is the IP for the VLANs. Then you have the actual IP and IP, and then the rest of the payload. All right. That's all there's to this. Not a lot of information, just showing you what you should be able to see when you're doing this. Again, you're not going to run into it in your exam. You're not going to run into it in your exam. What you're going to run into your exam is this right here, which is configuration. That is all it. Now, we go take a look at our topology. Let me go to my laptop real quick. And there's our topology. Nice and easy, no big deal. All right, we're already running EIGRP. Let me stand over here. This time I'm not going to get in your way so you can see everything. All right, so let's open up, let's say router 1. All right, router 1, there it is right here. Let's do a show IP route. Okay, and let me bring this, open this up some more so you can see better. Let's do it again. There we go. And you can see that you're running, which is D, okay, which is EIGRP. You have the 24, 28, 20, 40, 32, and 36. What's not included in there, it's the loopbacks, which we'll create in a second, okay? No big deal. But we have reachability across the network. We have reachability across the network. How do we verify? We can trace, we can ping, we can do whatever. So let's go ahead and just ping. This is the 20. So if this is the 20, let me get rid of this so you can see what I'm talking about. This is the 20. This is the 24. Then over here, we have the 28. I feel like Vanna White. All right, here we have the 32, the 36, and the 40. You want to buy a syllable? No, just kidding. All right. We're going to go ahead and ping from router 1. We'll go ahead and try and ping, let's say, the F10 interface over here. Now, just a little, I want to interject something real quick. At this level of the game, those of you that are watching this particular video, or even some of my older videos, I only put the network address. Okay? This is a network that's in between two routers. You should know that this could be 29 and this 30, or this 29 and this 30. You should know how to subnet at this point in game. When you guys and gals get to the CCNP level, there will be nobody showing you subnetting. There may be a review of 1 or 2 questions, and that's it. All right, and those of you that are seeking your CCIE, you will see GRE over DM VPNs. You most definitely will not get any. You may get a little bit of a review of regular IPv4 subnetting and IPv6 subnetting. All right, but other than that, you should know this. So whenever you see my labs, okay, let me get out of the way. I know big glass is always in the way. All right, whenever you see my labs, pause, create exactly what you see there. If you want to put this, and now this is how I usually do it. I start from here and I work my way around. Okay, so this is 20, 21, 22, broadcast 23, network 24, 25, 26, broadcast 27, network 28, 29, 30, broadcast 31, 32, 33, broadcast, oh, did I do that right? 29, 30, 31 broadcast, 32, sorry, 32, 33, 34, 35 broadcast, 36 network, 37, 38, 39 broadcast, 40 network, 41, 42. So I'm not going to put the actual IP address that's going to go in that particular interface because you'll see it configured, but you should know at this point what it should be based on the network and the mask. Okay? Word to the wise. All right, here we go. Let's start with router 1. What we're first going to do, we're going to do loopbacks. Now our loopbacks, we'll make them simple. We're going to make router 1, all 1s. Router 2, all 2s. Router 3, all 3s. Router 4, all 4. And we're going to use the 32 mask. Okay, the 32 mask. All right, so let's get this done. This is quick. As a matter of fact, let's open up Notepad because I have the configurations right here. All right, and because, we got to learn to be quick. For those of you who are taking your CCIE, Notepad will be your friend because you are allowed to use Notepad. How about that? All right, so we're going to go interface LO1. That'll create it. IP, and you can see that, yes. IP address 1.1.1.1, and then 255.255.255.255. You don't need to no-shut a loopback interface. They're virtual. They will come up on their own. What you need to do, though, is that you need to go inside EIGRP and advertise those loopback addresses. Don't forget that. And for UCCNAs, that goes as well. If for whatever reason, let's say I've been hearing a lot of OSPF, all right, and OSPF uses loopbacks a lot. So definitely make sure that your loopback address is within your routing protocol, that you're advertising your loopback address. Don't forget that. All right. So we can do it right here. We'll just say exit, and then we'll go router, EIGRP 100, because I know it's 100. Net, for short, network. Network 1.0.0.0. No auto hyphen summary. Now, and let's do this for good measure, do WR, which those of you that are taking the CCNA, because it's the CCNA, you can't do WR, okay? You can't do it. You got to go all the way back to privilege mode and do copy run start, enter, enter. Anyway, I've had questions. Laz, why, if you have the address 1111, why did you advertise 1.0.0.0? Any distance vector routing protocol, you can advertise the classful boundary of the address. This is a class A address, therefore the classful boundary is where that number 1 is. All right? So all I need to do is put that 1.0.0.0. Okay? If I were to put all the ones and you would have looked at the start, you would have seen that 1.0.0.0 anyway. And you can never, ever, 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 ever forget no auto summary. If you do, then it will summarize the address. And then you won't, your router will be like, yeah, I don't know where to go. You may get there, you may not get there. You never know, depending on how you set up your topology. So always put the no auto summary. Newer iOSs that are coming out, or they're already out, you may not need to put the no auto summary command. But for right now, especially for those of you that are taking the CCNA, for any distance vector routing protocol, whether it be RIP or EIGRP, you better put no auto summary. If not, you're going to be in trouble. Warning you now. All right, so we're going to go ahead and copy this. Let me make sure I'm out of your way. By the way, I don't know if you've noticed or not, this is a much bigger board. Since I was always in everybody's way, I said, you know what, I better get a bigger board because I'm going to continue to grow. All right. So we copied that. Now we're going to go ahead and go into router 1. And we'll put ourselves in global configuration. And let's see if we made any errors. All right, and then how about paste? There we go. Boom. Awesome. No big deals. It took everything without a problem. There's your loopback interface, and then we advertise it within EIGRP. Awesome. We're done with router 1. Let's bring router 1 down. Let's go to router 2. And since it's in Notepad already, it just makes life a whole lot easier because all I got to do is change this. 2.2.2.2. And I'm done. Isn't that wonderful? And this time I did a couple enters at the bottom. That way it'll enter the do WR. I don't have to do it. Control C. Config T. Conf T. My typing is horrendous. Let me bring that up a little bit. And we'll just paste that there. Boom. Done. Hey, I forgot to change the advertisement. That's fine. So what we'll do is we'll go back to Notepad because just a lazy way. 2.0.0.0, right? It's not the 1.0.0. So we'll go back and redo it. Copy. Paste. All right. But I trust, but I verify. So I got to make sure. Do show. You just look at the start. For me, it's a lot easier. It's not that much configurations anyway. All the way toward there we go. You can see that this could create a problem because I'm advertising the 1. So I want to make sure I go inside EIGRP and get rid of that network that I'm advertising. A little troubleshooting there. All right. So I'm going to do a Control C. I'm going to do EI or router EIGRP 100. And I'm going to say no space. Highlight this puppy right up here because I don't want this guy. Right click it, enter. I'm going to do a do WR. And then I'm going to do show start. And voila. Okay, here we are. We have, let me stand on this side. We have the EIGRP. We're advertising only the two network and the 10.0.0.0.0. All right. Let me make this a little bit more smaller. So bring it this way. Okay. All right. So that was router 2. So let's get router 3 ready. Let's not forget that we need to change the advertisement. Now that we did before. That was 3.3.3.3. No decimal point at the end there. Let's change that 2 to a 3. Let's copy paste. Oh, look, I haven't changed the loopback 01. It could be loopback 01 all the way across. Not a big deal. Just keep in mind exactly when you're doing your tunnel, the destination address, very important. Okay, and because we're all going to be using the loopback addresses as our source and destination. Okay. All we want to make sure is that our tunnel comes up. All right. I don't know if I copied it or not. Let me just do it again. All right. So we go to router 3. All right. I'm going to do a config T or conf T. And then I'm just going to paste. Whoa. Or I thought I was going to paste. Router 3. Paste. Boom. Done. All right. Now we go to router 4 or router 6, really. And the reason it's router 6 because we're coming this way. I'm not going to go back and go this way. So I'm just going to continue going this way. All right. So router 6. So that means this is 66666. 4 6s, not 3. Okay. Don't be scared. Make sure you advertise it. Get that little extra enters there. Control C. What did I say? Oh yeah, router 6. Router 6, conf T. Okay, can't type. And then we do a paste. Boom, done. Awesome. Let's prep now for router 5. 5.5.5.5. And then 5 right there, right? Notepad, very easy. Makes life easy. And whoever says in the real world that they don't use Notepad, they're lying to you. Okay. Conf T. Right click. Done deal. Now we go to router 4. 4.4.4.4. And go to 4. To advertise. Boom. Control C. Go to router 4, which is the last one. Conf T. Configuration terminal. And then paste. And we should be done. Let's minimize this. Let's go back to router 1 and just do a show IP route. Ooh, my language, am I speaking? Show IP route. And there you see we have our loopbacks, right? One we're connected to, then the ones that are being advertised, and then our networks that we've seen before. So now we have complete, all right, but we'll ping anyway, just so you can see ping 3.3.3.3. 4 bangs, right? That's what we want to see. And then we can ping, I don't know, 10.1.1.37. Okay, fingers work. And we have connectivity not only with our loopbacks, but with our physical interfaces. Now that we know we have reachability, right, across our network, we're using EIGRP. Okay. Get my pencil again. What we're going to do is we're going to create a tunnel, or GRE tunnel. Okay, a GRE tunnel. We're going to create a GRE tunnel this way. Right? Router 1 is going to be our source. Router 3 will be our destination. So packets flowing through there should flow through the tunnel. Our goal is to make sure that we create the tunnel and then the tunnel comes up. All right. Obviously, we need to advertise the tunnel as well. Now, I know I said earlier about recursive routing errors that you should create an underlay routing protocol on the outside and an overlay protocol on the inside. We're just going to do it an underlay, just the fact that you can see it gets routed, all right, and that the tunnel exists and it's up. That's the goal of this particular lesson, okay? So now you know what we're going to do. Let's go ahead and get it done, all right? And we'll start with router 1. And let me get rid of the pencil, obviously. And where is my routers? There they are. Okay. So go to router 1 and let's get rid of all that writing. Okay. And in router 1, what we're going to do, we'll go to global configuration. We're going to go create the interface for the tunnel. Interface, tunnel, and I tabbed there. Let's put 1. All right. Now you put the IP address of the tunnel. Again, this is just the way that I do it. Okay. You can put the source and the destination first, then the IP address. No matter. All right. IP address. I use something really weird so we can recognize it. 172.16.1.5, and let's use a 30 since this is a point to point, right? So here's our tunnel. Here's our IP address to the tunnel. And now we're going to create the source. Source is going to be, you can put the IP address, 1.1.1.1. Well, tunnel source, I should say. Tunnel source, 1.1.1.1. Okay. Tunnel destination is 3.3.3.3.3. That's it. That's all there's to it. You've created a tunnel. Okay. If you were, let me do WR. All right, Control Z. Control Z. I don't feel like doing do. And I'll do a show IP int brief. And there you see your tunnel 1 right here. Okay. That is up, obviously. Here's the other up down here because the screen is truncated a little bit. All right, but your tunnel is up, even though the other side, it should say up, down. But again, it's a simulator. Let's go now to router 3. All right, which we're going to do the opposite of what we did here. Here's router 3 right there. Okay, but we're going to do now the opposite. Okay, so we're already in global configuration. So interface, tunnel 1, could be whatever. Okay, IP address is 172.16.1.6. I believe that's what we used. Okay, and then tunnel source is 3.3.3.3.3, where the tunnel destination. All right, you can see I tab there. Lazy one. All right, that's done. I'm gonna do WR, do show IP in brief. always verify after you do something. Copy. There's your tunnel right there. Okay, there it is right there, and it's showing up. So let's see if we can ping. I'll do a Control Z. If we can ping our tunnel IP address 172.16.1.5, and we can. And we can. So now we just created a tunnel, a GRE tunnel between router 1 to router 3. So any information going that way, you would need to, obviously, if you want to secure, you will run IPsec, all right? Information to flow that way. Now, that's only part of it. That's just a basic configuration that if the test changes, more than likely, that's what you'll get, okay? For those of you taking the CCNP or CCIE, this is a very basic configuration of it. There are more things to it, but not for this particular lesson. This is your tunnel, all right? That's how you create it. That's it. Our goal was to create it and to see it come up and that we can ping our tunnel, and we can. And we can, and you see that I didn't advertise it in the routing protocol, okay? So now there are commands that you can use to trace to see if the data packet is going through there. You can use Wireshark protocol analyzers. You can use show IPsec for that particular network. It shows you what interface is going. So all these different things you can type afterwards. But it could be that you would need to run a different protocol within the tunnel. That will be the cleanest way of doing it. Or you can create filter lists, all right? Not so clean, but it is possible, filter list. So you can go ahead, or prefix list, well, to filter the traffic to go out the tunnel and not the interface, even though it has to go actually out the physical interface, but it's going to use the tunnel instead of the physical interface, okay? But that's it. That's as simple as it gets as far as GRE and IP and IP, because you probably say, hey, he didn't configure IP and IP. It's the same thing. The only difference is that you change the mode from GRE to IP and IP. I hope you enjoyed the lesson. More to come. See you then.